Alright guys, your essential question is, how do we use trigonometry to find the measures of the sides of right triangles? Your vocabulary includes angle of depression and angle of elevation. And just so you know, you will have a quiz over this material at a later date. Alright, let's go ahead and jump into today's lesson by looking at a problem. Let's say I were to give you a right triangle. I know that this is a right triangle because of this 90-degree angle for angle R. It says if angle P is 35 degrees, so this is 35 degrees right there, this angle, and sometimes you might see instead of a capital P with a little angle sign, angle P is 35 degrees, then it says find the value of side Q. So I want to find the value of this side. Well, what I'm going to do first is I'm going to label all of my sides according to this angle. So from this angle P, this would be my opposite side, Q would be my adjacent side, and then R would be my hypotenuse because it's across from the 90-degree angle. Alright, so I see that I want to find Q, and I'm given my hypotenuse, so Q is my adjacent, so I'm going to say cosine of 35 degrees is equal to Q over 14 because Q is adjacent and 14 is hypotenuse and cosine is adjacent over hypotenuse. So you have this equation. How are we going to solve this for Q? Well, the easiest way to do this would be to multiply both sides by 14. So the 14's across out on the right hand side, so that's going to leave me Q is equal to 14 times cosine of 35 degrees, and then plugging this into our calculator and rounding it to 3 decimal places, I would get the value of 11.468. And then even though it doesn't specify how many decimal places to round it to, for this lesson for today, I'm just going to round it to 3 places. Alright, let's look at another problem. Most of the problems that we're going to be doing for today are word problems. So let's start by looking at this one. It says the circus has arrived and the workers must put up the main tent in a field near town. So there's my main tent. It says a tab is located on the side of the tent 40 feet above the ground. So if you could imagine, there is a tab that's 40 feet above the ground on the tent. So let's just say the tab is right here. So that means that this distance is 40 feet. Okay, it says a rope is tied to the tent at this point, and then the rope is placed around a stake on the ground. So there's some sort of stake on the ground. It's not a ribeye stake, it's just a stake, a metal stake or a pole. And it says if the angle that the rope makes with the level ground, so the angle that the stake makes, there's the stake, with the level ground is 50 degrees and 15 minutes, how long is the rope? Alright, so remember, this is the distance on the ground right here. So this is the distance on the ground. I'm just going to call this X, and then this would be the distance of the rope. So I'm just going to call that Y. It says how long is the rope, and what is the distance between the bottom of the tent and the stake? Now it doesn't look like it, but this is a right triangle because this forms a right angle perpendicular with the ground. But the issue with this problem is that we haven't worked with minutes, so I'm not really sure how we're going to type this into the calculator. So before we can tackle this problem, I need to show you how to convert minutes and seconds into decimals. Well, here are the main 2 principles you've got to know. There are 60 minutes in a degree, so divide the minutes by 60. And then we all know that there's 60 seconds in a minute. So divide the seconds by 60 times 60, or 3,600. And this is how we're going to convert our minutes and seconds to a decimal form. For example, this is, read, 39 degrees, 5 minutes, 34 seconds. And I'm going to make a note of that. So this is my degrees, this is my minutes, and this is my seconds. So I want to convert that into a decimal. The way that I would do this, I'm going to write it out for you. My degrees I'm going to leave alone, so I'm going to have 39. But for my minutes, I'm going to have 5 divided by 60 plus 34 divided by 3,600 because there's 60 seconds in a minute and there's 60 minutes in a degree. So what I'm going to do is use my calculator. 5 over 60 plus 34 over 3600, and if I round that to 3 decimal places, that's going to give me 0.093, and so don't forget about the 39, so I'm going to have 39.093 degrees. So this is equivalent to this. It's just this is written in decimal form, and this is written in minutes and seconds form. Now the great thing about your calculator is that your calculator will allow you to put minutes and seconds. However, it's still crucial how to know to convert minutes and seconds to decimals, because you might not always have your calculator handy. Alright, so let's take a look at the second one. So to convert this, 23 degrees, 14 minutes, 30 seconds, what I'm going to do is I'm going to leave the 23 alone, and then I'm going to have 14 divided by 60 plus 30 divided by 3600. Type this into the calculator, it gives me 0.242, and now I'm going to tack on my 23, so that would be 23.242 degrees, and that would be the answer for that one. Alright, for the third one, I'm going to leave the negative 405 alone, and I'm going to have 16 minutes divided by 60, and then 18 seconds divided by 3600. That'll give me the decimal 0.272. Now I'm going to tack on the negative 405, so negative 405.272 degrees, and that would be the answer for the conversion for that. Alright, so now that we know how to convert minutes and degrees, let's go back and revisit that problem one more time and draw this scenario again. So my tab that's at the top of this tent, this is 40 feet. I don't know how long the rope is, so I'm just going to call that X. I don't know how far the stake is from the bottom of the tent, so I'm going to call that Y. But I do know that this angle is 50 degrees and 15 minutes. So what I'm going to do is I'm going to convert this, so 50 degrees and 15 minutes. So that's going to be 15 divided by 60, and that'll give me the decimal 0.25. Now tack on the 50, so that'll be 50.25 degrees. So 50.25 degrees. Since this is my angle, the 40 is going to be my opposite. My X is going to be my hypotenuse because it's across from the right angle, and the Y is going to be my adjacent. Alright, doesn't matter which one I solve for first, so I'm just going to solve for the rope since it asks for how long is the rope first. So this is my angle, opposite over hypotenuse. That means I'm going to use sine. So sine of 50.25 degrees is equal to opposite, which is 40, over X. Alright, now it might look a little bit difficult how to solve this for X. So what I'm going to do is I'm going to put this sine of 50.25 degrees over 1. That way they're both fractions. So I'm going to cross multiply, and then that's going to give me X sine of 50.25 degrees equals to 40, because 40 times 1. And then to solve this for X, I'm going to divide by sine of 50.25 degrees. And then so that cancels out. And so X, if I use my calculator, 40 divided by sine of 50.25 degrees, that's going to give me 52.026 feet. And like I said, just for this lesson, I'm rounding to 3 decimal places. You could just approximate that as saying that's 52 feet. Alright, let's solve for Y now. Now, Y is adjacent. You know what the hypotenuse is now, so you could, if you want to, you could use cosine. But since I already have opposite and adjacent, I'm going to use tangent. So tangent of 50.25 degrees is equal to opposite, which is 40, over adjacent, which is Y. Again, I'm going to put this over 1 so that I can cross multiply. And so that's going to give me Y tangent of 50.25 degrees equals 40. To solve this for Y, I'm going to divide by tangent of 50.25 degrees. And so that would give me, using my calculator, 33.268 feet. Or you could say that's about 33 feet. Alright, so basically we're going to be using our trig ratios to solve word problems. But there's a couple of vocabulary words that I need to go over before we can start jumping into these word problems, because one of the common vocabulary terms that's used with trig ratios are angle of depression and angle of elevation. Now, most people are okay with angle of elevation. Angle of elevation is the angle that's formed from the ground level and whatever site you're looking at. So like, for example, if somebody is right here looking up at that jet, then the angle of elevation is 20 degrees. Now the angle of depression is depression like going down. So if somebody's up here in the plane and they're looking down at this ship, the angle of depression is not this angle right here. It is actually this angle that's right there. Now, remembering your geometry skills, if you remember, alternate interior angles are congruent. So what's important and what you need to, the key concept to take home with this is that the angle of elevation is always equal to the angle of depression. And my handwriting is very sloppy on that, but basically, if they tell you the angle of depression, just know that that value is equal to the angle of elevation, and so that way when you draw your triangle, you'll know that that angle, whatever it is, goes in this corner right there, or basically at the bottom of the triangle. So that's the key thing. It's just knowing that the angle of depression is equal to the angle of elevation. Alright, so let's look at another example. It says the Ponce de Leon Lighthouse in St. Augustine. It's very pretty also. If you've never been to St. Augustine, great place to go for a vacation. Alright, is the second tallest brick tower in the United States. It was built in 1997 and it rises 175 feet. So this tower is 175 feet. Now obviously this isn't the real lighthouse. I just borrowed it from Google. Alright, it says how far from the shore is a motorboat. So let's say we got a motorboat out here. So let's say right there, there's my motorboat. If the angle of depression, keyword there, from the top of the lighthouse is 13 degrees 50 minutes. So if you could imagine somebody up here looking down at this boat, the angle of depression is really this angle right here. But remember, the angle of depression is equal to the angle of elevation. So if this angle is 13 degrees and 15 minutes, that means that this angle is 13 degrees and 15 minutes. Alright, so it wants us to figure out how far from the shore is the motorboat from the lighthouse. So it wants to know what this distance is right here. So this is the angle I'm given. 175 would be opposite, and this value for x would be my adjacent. So I know I'm going to have to use tangent. So I'm going to do tangent of 13 degrees 15 minutes is equal to 175 over x. Again, I'm going to put this over 1 so I can cross multiply. So I'm going to get x tangent of 13 degrees 15 minutes is equal to 175. And to solve this for x, I'm going to divide by tangent of 13 degrees 15 minutes. If you notice, I didn't convert the 13 degrees and 15 minutes because you could try typing this into your calculator, and you'll know if you get it right if you get 743.198 feet, or approximately 743 feet. Now, the great thing about trig, and the reason why trigonometry was invented was for this very reason, was actually to measure distances and travel, especially when the early explorers were traveling the Earth, so latitude, longitude, all that kind of stuff. That's really where trigonometry came from. Now, you can go back in history and look at a lot of the other trig that happened before that, but for the most part, the trig that we study was really developed during that time. Alright, let's look at one more problem. This is the last one, and it's a little bit of a harder, it's more of a challenging one. It says on May 18th, 1980, Mount St. Helens, a volcano in Washington, erupted with such force that the top of the mountain was blown off. To determine the new height at the summit of Mount St. Helens, a surveyor measured the angle of elevation to the top of the volcano to be 37 degrees 46 minutes. Alright, so let's imagine that you got this guy out here. He's trying to figure out how tall the mountain is, and obviously we can't just measure it with a tape measure, so we got to use some trig. So he looks up at the mountain, and he measures that angle of elevation is 37 degrees and 46 minutes. Then the survey moved 1,000 feet closer. So if you can imagine, he moves 1,000 feet closer, And so now he's right here, and now he looks back up at the mountain. So notice it's at a different, let me draw that better. Notice that it's a different angle, and this is 40 degrees, 30 minutes. Now, the mountain hasn't moved, he's moved, and so his angle of elevation towards the summit has changed. It's actually gotten steeper. Now, if you notice, this is a right triangle because there's my right angle. You notice you've got two triangles here. It says determine the new height of Mount St. Helens. So it wants to know what this value is. So we're just going to call that y. Now, one other thing I want you to notice is we don't really know the distance the guy is from the mountain, so we're just going to call that x. Alright, what I'm going to do is I'm going to look at two triangles. I'm going to look at the really, really big triangle, and I'm going to look at the very, very small triangle. So let's talk about the big triangle first, so the one with the angle 37 degrees, 46 minutes. If I label this, y is my opposite, and then my adjacent would not just be 1,000, but it would be 1,000 plus whatever this value of x is. So it would be 1,000 plus x. So if I were to write that out, tangent of 37 degrees, 46 minutes would be equal to y over 1,000 plus x, opposite over adjacent. So there's my big triangle. Alright, now let's talk about the smaller one. Same thing, tangent of 40 degrees, 30 minutes would be opposite, which would still be y, but notice that this time the adjacent would just be x. Alright, what I'm going to do is I'm going to cross multiply both of these. So the one on the left, I'm going to put this in parentheses, 1,000 plus x times tangent of 37 degrees, 46 minutes is equal to y. And then for this one, I'm going to have x tangent of 40 degrees, 30 minutes is equal to y. If you notice, both of these equations are set equal to y. So that means since both of these equations are set equal to y, I can set these two equations equal to each other. And so what I'm going to do is I'm going to do that right now. I'm going to take this off to the side, and I'm going to set these two equations equal to each other. So I've got 1,000 plus x times tangent of 37 degrees, 46 minutes. So that's one. And the other one was x tangent of 40 degrees, 30 minutes. Alright, I'm going to do some algebra to this, and the first thing I'm going to do is I'm going to distribute this tangent, 37 degrees, 46 minutes, to each one of these terms, the 1,000 and the x. So that's going to give me 1,000 tangent 37 degrees, 46 minutes, plus x tangent 37 degrees, 46 minutes is equal to x tangent 40 degrees, 30 minutes. Now, if you notice, I do have an x on either side, so what I'm going to do is I'm going to move this x tangent over to the other side, so I'm going to subtract it when I move it over. So the 1,000 tangent of 37 degrees, 46 minutes is going to be left alone, and so I'm going to have x tangent of 40 degrees, 30 minutes minus x tangent of 37 degrees, 46 minutes. I notice that now that I've got these two x's on the same side, they're in common, so I can factor that x out. So I'm going to have x and then tangent of 40 degrees, 30 minutes minus tangent of 37 degrees, 46 minutes, and that's still equal to 1,000 tangent of 37 degrees, 46 minutes. If I want to solve this for x, I'm going to divide this by this. I know it looks like a horribly long expression, and it really is. I'm going to divide both sides by that, so 40 degrees, 30 minutes minus tangent of 37 degrees, 46 minutes. So then this crosses out, and that just leaves me x. Now this looks like a horrible expression, and trust me, back in the day, without your calculators, this would have been horrible to calculate. However, you can type this whole value into your calculator. So hit Control Divide to make the fraction. Type this in exactly as you see it, and once you've done that, you can pause the video, but start it back up. You should get 9,765.826 feet. Alright, now let's go back to our picture. So that's just the value of x. that value of x that we got was 9,765.826 feet. That's just the distance the guy is from the mountain. What we want to find is the height of the mountain. So since we found the value for x, which is 9,700 odd feet, we can plug that into this equation and just do that value times tangent of 40 degrees and 30 minutes, and that's going to give us our height, or our value of y. So again, pause the video, type that into your calculator, but you'll know you got it right if you get 8,340.803 feet. So we can use trigonometry to find the value of that mountain. It was approximately 8,340 feet. Alright, that's it for today's lesson. By all means, go back and rewind it and watch it over again if you need to. Alright.